Hello. Today this video is going to be slightly different to the videos on Maths Watch. I'm going to hopefully present this in a structure that's similar to your lessons at school. So there's going to be a do now, a starter, and then a couple of examples, and then some questions for you to have a practice. And all of that's going to be in this one video. It's important that when I'm going through the video, you are pausing it to give yourself enough time to write down the working out and then get your answer, and then you can press play again and then check your answer and then mark it. Okay, so what we're going to learn about today is mixed numbers. So what are mixed numbers, and hopefully look at how we can convert between mixed numbers and improper fractions. First thing I'd like you to do is write down these two questions that I've got here, and can you have a go at those? Write down all of your working out, pause the video, and then press play again when you're ready to see your answer. Okay, so I'm just going to delete this box. There's going to be some working out. And for the first question, we've got a fifth plus 2/5, which we've got written down here. And 1 plus 2, because the denominator is the same, they've both got a 5. So we can add these straight away and get 3/5. For this second question, 5/6 take away 1/6. Again, the denominator is the same, and they've written it as one fraction, 5 take away 1, gave them 4/6, which then simplifies to 2 over 3. So once you've got this answer, always check, can you divide both of the numbers by any number? And in this case, 4 and 6 divides by 2, which is where we've got 2/3. Mark those, and then we can move on. Okay, the outcomes then. So first of all, it's really important that you know the difference between the denominator and the numerator. Then we're going to look at converting between mixed number and improper fractions. And if you're feeling really confident with that, then you'll be able to order some mixed number and improper fractions as well. So let's have a look at the starter then. Please can you write down the two questions, question A and question B. Pause the video while you have a go at working this out, and then press play again when you're ready to see the answer. Okay, so I'm going to delete this box and show you the working out. This time, a fourth plus 2/5, the denominator is not the same. So what they've found out is that the lowest common multiple of 4 and 5 is 20. And they've converted a quarter and 2/5 into equivalent fractions with denominators of 20 now. So the first fraction, a quarter, they've multiplied that by 5. 4 multiplied by 5 is 20, and 1 multiplied by 5 is 5. The second fraction, they've got 2/5, and they're trying to turn that into a denominator of 20. So 5 multiplied by 4 this time will give them 20, and they have to multiply 5 by 4 and 2 by 4, which is where they've got 8 over 20. The steps from that point are similar to the do now, where they can write it as one fraction with a denominator of 20 and then add the two numbers together to give you 13 over 20. Question B, it was a similar process, apart from this time you've got a subtraction instead of an addition, which was on question A. So they've found out that the lowest common multiple was 12, written that as one fraction, and then found the final answer as 5 over 12. Mark those please, and then we can move on to the example questions. Okay, so what we're going to look at is converting mixed numbers, which we've got an example at the top. This is a mixed number, and we're going to convert that into an improper fraction. An example of an improper fraction is this one here, where the numerator, in this case 11, is bigger than the denominator, which is 2. If I just go back quickly, all of these fractions here, these are what we call proper fractions, because the numerator is smaller than the denominator, which is what we're used to looking at. Again, 2/3, 2 is smaller than 3, and it just looks like a normal fraction. So the first one, we've got 4.5. I'm going to show you a couple methods of converting these into mixed numbers and improper fractions. So please can you write down everything that I go through on this screen, and then that will help you answer the questions on the next page. So write down 4.5. It means we've got 4 whole ones and an extra half. And the first way that I'm going to show you is using a diagram. I'm going to use a bar model to represent this, and to decide how many squares I need to use in each bar, I'm going to look at this denominator here. So I've got a denominator of 2. So each bar is going to look like this. It's got 2 squares in each bar, and 1 bar is going to represent a whole one. So that there is just going to be my key, really. Okay, so that's my key. So this bar is just showing you what this is going to represent. So my key there, let's have a look at this, see if we can get it. Okay, so key equals 1 whole. And in each square that would be a half. Having a look at this example then, we've got 4 wholes and an extra half. So what I need to have a look at then is, if this here represents my 1 whole, which is 2 squares, I chose that because I've got a denominator of 2, I need 4 bars because I've got 4 whole numbers to the left here. It says 4 whole ones. So I've got 1, 2, 3, 4. As well as these 4 whole ones, I've also got this extra half. And to represent that, instead of 2 squares, I need to represent that using 1 square. I've got my 4 whole ones here, 1, 2, 3, 4, and an extra half. And I need to see how many halves is that in total. So I'm going to count all of the squares. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 and a half equals 9 halves. This is really tricky using the mouse instead of writing on the board like at school. Okay, so hopefully that's clear. So we've got 4 and a half here, which equals 9 halves in total. As well as using the bar models, I'm also going to show you a different method that we can use that doesn't involve drawing and just using the numbers in a calculation. So first of all, I've got my 4 wholes and I want to see how many halves are in those 4 wholes. So I'm going to take this whole number 4 and multiply it by the denominator. So 4 multiplied by 2 is 8. And that's telling me that in those 4 wholes, I've got 8 halves. My second line of working out, as well as these 8 halves in this whole number, 4, I've also got this extra half to the side. I've got 1 extra half. So I'm taking the 8 that I've just found out and I'm plussing 1 this time to give me 9. And we get the same answer, 4.5 equals 9 over 2. When you're doing the questions on the next slide, it's really up to you. If you want to draw the diagrams or if you want to use the sort of number method of working out, is really up to you. The next question, we've got 11 over 2 this time. So on this question, we're going to convert an improper fraction to a mixed number. And again, what I'm going to use is the bars to represent this number and then see how many wholes we've got and how many left over. And the denominator for this again is 2, which is the same as this example up here. So the key is going to be the same. I'm going to use 2 squares because I can split 2 easily in half, and my whole one's going to be 2. And what I'm looking for is I've got 11 halves. So what I need is 11 squares. So here I've got 2 squares. Now I've got 4 squares, and I'm just going to count up until I reach that number 11. So now I'm up to 6, 8, 10. Now if I draw another full rectangle, that'll give me an extra 2, so it'll be 10 plus an extra 2, that'll give me 12. I don't want that, I want 11, so I can't draw a full rectangle, I'm just going to have to draw another square like that. So in total I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is my 11 halves. And I just need to see now how many holes is that and how many left over have I got. So that's 1 hole, 2 holes, 3, 4, 5, and this bottom row, it's not quite a hole, it's just going to be an extra half. So in total I've got 11 halves equals 5 holes and 1 half. Like that. As well as using the bar models, we can also use the numbers like we did, similar to on the last example. So this time we've got 11 over 2. And this fraction line here, what that means is divide. So it's telling me 11 divided by 2. How many times does 2 go into 11? And the way that we know how to divide numbers, the method that you all know, is using the bus stop division. The numerator, which is 11, is inside the bus stop, and the denominator, 2, is outside the bus stop. So we're seeing how many 2's go into 11. If we think about the 2 times table, we can go up 2, 4, 6, 8, 10, 12. So we know that 11 isn't quite in there, so we know that we're going to get a fraction as part of our answer, and we'll just see how that comes about. Okay, if you divide 2 into 11, this should be your working out. First of all, I'm checking how many 2's go into 1. Well, I can't do that, so there'll be 0 on the top, and I need to cross this one out and carry 1 over, and that now becomes 11 here. So how many 2's go into 11? Again, 2, 4, 6, 8, 10. That's 5 2's, which I've got on the top of our division. And I'm going to write down what the remainder is. So there's 5 2's in 11, which would give us 10, and there's also 1 left over. So the difference between 10 and 11 is 1, so there's going to be a remainder 1. It means I've got 5 holes and an extra 1. And that's going to show us our answer. So we've got 11 over 2, which is what we started with, equals 5 holes, which is on the top of our division, and an extra 1 half. And this 1 is coming from that remainder there. Hopefully you've got all of those examples written down into your book. The first one, again, that's converting a mixed number into an improper fraction. And this second example was converting an improper fraction into a mixed number. And you can either use the bar model or the multiplying and dividing to get to your answer. Both of those will give you the same answer. On the next slide, I'm going to put on some questions for you to have a practice. Have a go at the ones that you're confident with. Don't spend too long on these. I don't want you to get too bogged down if you're struggling. Here we go. So we've got the first set of questions will relate to the first example that I talked about on the last screen. The second set of questions here in the middle will talk about the second example that I talked about. And this third set of questions, I didn't talk about an example, but what you're going to have to do is convert both of them into improper fractions or mixed numbers and then compare them. So which one's the biggest and which one's the smallest. This bottom section and the star question are going to be your extension questions. Really, the first two sections are the most important that I really want you to focus on. So pause the video while you have a go at these questions, take as long as you need, and then when you're ready to see the answers, press play, and then the answers will come up. If you want to see the answers, check the ones that you've done, press play, and then just take the video back a bit so you can do more questions. Pause the video now if you would like. Okay, here's your answers. This is for the first section. This is for the second section. This is the third section. And then this is your extension question.